We've got it all for you this week, my friends. Starship version 3 testing action along with all the other exciting news at Starbase. SpaceX has also completely flipped the table over, ditching any Mars mission that we thought may come over the next few years to now focus on a lunar base instead. Loads of flight action for Falcon 9, including another Crew Dragon mission, another strange issue with Vulcan, and much more. So let's get into it.
Okay, Neil, we can see you coming down the ladder now.
Hey, Marcus Housewithy here, and we of course left you last week with the exciting cryogenic proof testing that was well into its run for Super Heavy Booster 19. It has been awesome watching SpaceX prepare for the first version 3 flight of Starship coming soon. This fourth cryo test was already being done just hours after our last video went live, all starting off in daylight hours. It was another full load too, and all the valves were on point doing their thing to relieve any of that excess pressure. After the series of tests, SpaceX posted a neat time-lapse early in the week showing this fourth test as the day transitioned into night. Because this is the first time that we've ever seen views like this with the new integrated hot staging on top, we had never seen the dome frosted over completely like this, and of course they didn't disappoint with the incredibly detailed photos of all of this. I think it's going to be crazy seeing the 6 Raptor engines above on the Starship upper stage fire up and blast to the top of this during the separation, especially for the first time. As stated, the testing had been completed as they ran through everything needed to be confident with the structural strength. This is critical, obviously, especially considering that the hot staging system, the entire aft engine plate, and the complex plumbing alterations for the Raptor version 3 have been completely redesigned. Just think about that new near Falcon 9 sized transfer tube inside. Almost everything here is different, and the multiple days that they have spent testing this in a variety of ways is a great sign. Anyway, with all that ticked off, it was time to take it back to the build site for checks, and we hope the installation of the 33 Raptor version 3 engines. RGV aerial photography flew just at the right time to pick up some sweet views of it before it rolled back. With this neat perspective, you can see the added steel plates on top to protect the forward dome during that hot staging. Shaun was out here to watch it roll back just as he was here to watch it roll out in the first place. As always, thanks for being here watching so that we get to be out there picking all this up for you. The events only get more exciting from this point after, I will admit, a more lengthy time than we had expected waiting for flight number 12. There is still a lot to get done though, and everything will need to run like clockwork if they are really serious about a flight by mid-March, which is roughly the 6 weeks referred to here almost 3 weeks ago. In the early hours of Monday morning, we could see the Super Heavy rolling towards Megabay 1 thanks to Avid Space's live views. Indeed, our views are restricted more these days with the Gigabay work in front, but we can see enough to know what's going on. After the sun rose, the doors closed and the transport stand was hours later already heading back out to be stored in the Sanchez area of the site. Since then though, we've been anxiously awaiting the updates on what comes next. I'm very excited to see how the static fire test campaign is going to play out at the new Pad 2. After all, they're not just testing the booster itself along with the 33 version 3 Raptor engines together for the first time, they are testing the deluge system, the flame trench, all the new ground systems and the propellant farm. It is everything. It almost reminds me of watching the first static fire test at Pad 1 years ago. Another chunk of action for the next vehicles in line for the following Flight 13 as well, starting with another 2 separate ring sections for Booster 20 rolling into Megabay 1 this week. The first was moving here on Monday, and the second on Thursday came out with fixtures for the Strakes. So in total, we have 4 sections of the liquid oxygen tank here now, which should all be stacked at this point. In Megabay 2, Ship 40, which is presumed to be flying on Mission 13, had its common dome section appear on Thursday as well, so it's all moving. Now, looking at the Gigabay, the third level is essentially complete at this point with walkways now on both sides of the bay. SpaceX seems to be waiting on getting a bunch of outfit work done on the existing levels before kicking fully into Level 4. These walkways between the aisles seem to be providing structural support and easier access as it all grows taller, but I imagine those will be removed at some point because they're too low for the vehicles to roll through. Over to the launch site, last week SpaceX had jumped right into the new site expansion with fencing being installed around the perimeter, and this week we can see the entire brand new site boundary. This expansion pretty much doubles the work area that SpaceX has to play with here now. Based on the plan, you may remember the methane production will be installed here on site, similar to the idea that they are running with for the air separation unit. This, though, will produce the fuel on site, which should have them massively reduce the off-site deliveries. The sooner they can replace the hundreds of tankers, the higher their launch frequency can grow. We can see here the concrete along the old site border is being broken out as the existing vegetation is also cleared. Even since this flyover, there has been many trucks both importing and exporting dirt and sand, so in just a few weeks, the difference is going to be staggering. Now there is this brand new D5 road which should be the new entrance coming off the roundabout. Shaun has some ground shots of this entrance being built up, which is heading right in toward Pad 1. Speaking of, at the Pad 1 launch site being upgraded, they've recently pulled the tower arms open manually given everything has been disconnected. They used cables on the end of the arms and ground equipment to just pull them open. Hey, if it works, it works. This week we could see them drilling in the area below the arms, so they likely just needed to have them open to allow clearance for the drilling rig. I think they must be getting quite close to being done with all the concrete pile work here because the sheet piles still being delivered are now being installed too. Here is Pad 2 for reference once all these sheet piles were installed back at the end of 2024. Checking in on the tank farm expansion nearby, this week we can see all 4 of the new tanks are now in place. Once hooked up, they should presumably replace these smaller methane tanks over here, which SpaceX installed in 2022. To further support that theory, workers installed scaffolding on either side of the lift points, so we may see a crane come over here to get started removing these in the not so distant future. Moving over to Pad 2, quickly preparing for Flight 12, we had a new FAA filing published this week, which matches up with all these crane pieces being delivered as we speak. It seems we have an LR11000 crane being prepared to install a new roof on Tower 2 at 180 metres in height, so that's going to look amazing once done. Shaun could see workers up here throughout the week putting in supports, it seems, just to strengthen the roof structure in preparation for all of this. Now, heading to Massey's and the continuation of the test article updates, the bottom half of this B18.3 article is still here. This had been lifted off the can crusher and onto a normal ring stand, so it's likely that they will just scrap this entirely right here on site. The transfer tube section in the middle had already been cut out and is standing nearby, as we can see thanks to RGV's views from above. Just as a side note, the other half of this still seems to be getting actively worked on in the Star Factory. We could see through the windows with NSF's live cameras here, and we could see them beginning to remove the hot stage truss sections from the top. It's still unclear what their intentions are with this, but if they were simply scrapping it, it would have been done much more unceremoniously, I imagine, so I suspect there is at least some of this being reused. Anyway, although they are scrapping the bottom half of this, in the larger can crusher beside, we also have the much more successful B18.1 test tank. This has been slowly unhooked to be freed from its cage now that its 17 cryogenic proof and stress tests have been completed. With that awesome RAM system in this testing cage, SpaceX would have simulated dozens, perhaps even hundreds of different flight scenarios. Late this week, we could even see them lifting this out on Thursday for the first time since it was installed back in May last year. Now, the big twist this week, of course, was SpaceX not just kind of changing direction slightly, but more flipping the table on the whole Starship plan for Mars. As we all know, Starship as a methane oxygen-powered vehicle has primarily had the target of landing cargo and humans on Mars, given that the fuel can be extracted predominantly from the atmosphere. The moon to SpaceX has been considered over time as being a bit of a distraction, but with Artemis missions coming, it seemed a good opportunity to get in on some lunar action as well. Remember, there was a loose goal to try to send a demo Starship to Mars at the end of 2026, but not only has SpaceX cancelled that idea, they've now pushed the Mars plan well down the line at least 5 to 7 years. This was a very strange thing to see happen for all of us that have been watching right from the early days of the interplanetary transport system, which then became BFR, which then evolved into what Starship is today. Instead, now the focus has flipped to sending huge amounts of cargo and infrastructure to the moon with the ultimate goal of having a lunar base built. Eventually, it seems, with the capability of making a factory pumping out satellites. Satellites that would be then launched into space with a mass driver on the lunar surface. It all sounds very fantastic, doesn't it? And of course, much of this is well down the line, but the thinking here is that unlocking the resources of the moon will make SpaceX's goals moving forward more practical. More on that in a moment, but first there's a strange behaviour that cartridge raisers have trained into us, pressing harder. Why would a tool designed to touch your skin need force to work at all? I think over time, with all the disposable razors we've seen and used, you would think that pressing harder while shaving helps get a closer shave. Turns out it is more a workaround of these expensive disposable cartridge razors. You know, the way they put blades on springs with these cheap plastic materials. This over time has trained us to press firmly, otherwise the blades will bend and deflect, tugging on each hair. If you press in harder though, the friction rises, and that means you've got multiple blades now irritating your skin. If the first blade has cutter hair, any more blades running over the same spot is just causing razor burn for no reason at all. With the pressure that you need to keep it feeling firm against your skin, all of a sudden you realise that this is really a learned workaround for an unstable design. You actually don't need multiple blades or these plastic spring-loaded flexing units at all. What you want is a blade that doesn't need pressure to feel stable, and that's the idea with Henson's AL13 razor. Given this has been machined from solid aluminum with a single blade held right along the full width, there is no flex. Minimal pressure is actually needed, and you hardly ever need to pass it back over a second time. They are really cost effective too, because you are just quickly switching out an affordable standard double-edged blade. They are offering 100 blades completely free if you want to pick up the AL13, by the way. Just head to hensonshaving.com and pick the colour of razor that you like. Add in the 100 blade pack to your cart and enter the code Marcus in the checkout process for the blades to pop up free. Thank you, Henson Shaving. Okay, so back to SpaceX's wild shift to focusing on a lunar base. Launching mass, whether it be satellites, raw materials, and even supplies like water, is incredibly energy intensive if it all needs to be launched out of Earth's gravity well. Launching that same mass from the moon requires much less given the low gravity and lack of atmosphere, especially if most of this can be done with a mass driver, and we know that the moon has gigantic stores of hydrogen, oxygen, silicon, iron, magnesium, and much more in smaller quantities, so there is a lot here to harness. Of course, all this comes right after the news last week that SpaceX wants to get approval to launch 1 million data center satellites into orbit. Regardless, as we tend to see, this idea comes with basically no detail at all at this point, so we know nothing about the plan for each step of these goals. Look, I personally think that we need to be a little careful dreaming too far down the line, as it can sort of take away from some of the excitement in what is coming in the short term. A project like a sustainable moon base, which includes operating a mass driver, could take decades to pull off, but each tiny step in this direction would be an amazing achievement. I would just love SpaceX to start sharing the details of some of those more near-term missions. The idea of a human settlement on the moon or Mars is inspirational in either case, but with Mars we are only able to send missions when the planets align every 26 months or so, and it's a 6-month journey with no simple means of return at this stage. Lunar missions, on the other hand, can launch multiple times each month, and it's really just a 2-day trip. No matter how you look at it, the moon is a stepping stone, and building a substantial base on the surface is much easier than Mars. I guess the feeling that I'm getting from a lot of you though in the comments and feedback is a sense of sort of whiplash. It wasn't that long ago that it was stated that no, we are going straight to Mars, the moon is a distraction. Yes, that was just a little over a year ago. I guess in the whole time that we've followed this, Mars as the goal has always seemed the constant mission that was never changing, but it is certainly no secret that XAI and huge constellations to evolve with this technology has twisted that narrative quite rapidly. In the end, I guess, low-cost mass to orbit is the goal no matter what the application, so this year we want to see this finally being unlocked. Then the dreams of the future, regardless of the direction that they take us, will start unfolding, and we can't wait to see it. Falcon 9 was back again just hours after my video went live last week. SpaceX had of course returned to flight just 4 days after the second stage anomaly last week had it unable to complete its deorbit burn during the Starlink Group 1732 flight. In the end, that second stage, with the aid of some controlled venting, was still able to re-enter Earth's atmosphere about 10.5 hours later anyway. The FAA had greenlit the beast to fly again after a SpaceX-led investigation, and here it was with booster 1088 carrying another 25 Starlink satellites in the Group 1733 mission after the Vandenberg liftoff. That was all followed by the landing on the drone ship Of Course I Still Love You, and that was the booster's 13th successful touchdown. The Group 1734 mission was also away from the same pad on Wednesday morning with an almost new booster 1100 only on flight number 3. Of Course I Still Love You was downrange for this one again after just those few days. Now, SpaceX did clarify that the second stage engine issue was caused by a gas bubble in the transfer tube. Over time, they have been running tests and refining that engine chill and deorbit procedure, and you can tell just how successful the team has been by the very few issues that ever pop up. Depending on the mission, they can't always deorbit a second stage. If the orbit is just too high, as an example, they won't plan one. Even still, in 2024, only 13 out of the 134 upper stages remained in orbit. Last year, it was only 3 out of a total of 165 launches that remained in orbit. That is amazing, and out of the 16 in those 2 years with the second stage still in orbit, 6 of those have naturally re-entered anyway, so that only leaves 10, and every one of those had flight plans where they just simply couldn't be deorbited anyway. With those, they are all accurately tracked so that everybody knows where they are. Anyway, back at Cape Canaveral, you may also remember a week ago we were talking about the 39A crew access arm coming down. Well, it has been removed this week, and now we have a little more information on this. I had mentioned last week that we thought that this would never return, and although that may end up being true, a little correction on that because we got some clarity from SpaceX's launch director saying that they would be doing some maintenance on the arm while having it cleared out of the way for Falcon Heavy and Starship launches at the site. It will essentially stay removed, it seems. However, they are keeping it stored away just in case they need to fly from Pad 39A with Crew Dragon again. That makes sense, of course, because if there is some issue at the other launch site, this gives them the option to quickly get this pad supporting crew again. It does seem, though, like this might be a long shot at this point. With that, of course, we had NASA's Crew 12 mission from Slick 40 taking the next crew rotation to the International Space Station just yesterday. On board, NASA astronauts Commander Jessica Meir and mission pilot Jack Hathaway, along with ESA astronaut Sophie Adano and cosmonaut Andrei Fadeev. Another young Falcon 9 booster 1101 on its second launch here, and this one had the propellant margin to make it all the way back in this return to launch site mission. Now, as you might remember, this mission was pulled a little earlier forward than planned because of the medical emergency requiring an early Crew 11 departure. This has had the station running with just 3 crew up there over the past few weeks. Now check this out, this is a great shot here coming back to touchdown on the brand new landing zone 40 right next to the launch pad. How cool is that? Moments later, there is the separation of Crew Dragon Freedom, and this should be autonomously docking with the station just a few hours after this video goes live. During the 8-month stay, the crew should be doing some intriguing work here. One such experiment is testing pneumonia-causing bacteria to hopefully help improve treatments on Earth, and they are also going to be testing some systems that can generate IV fluids on demand, which is a key capability for future deep space missions where resupply really isn't an option. It was an interesting mission as well for United Launch Alliance's Vulcan rocket late in the week. Another challenging flight here with an anomaly going on as the USS F-87 mission in the VC-4S configuration blasted into the sky. This had on board the GSSAP 7 and 8 satellites, which were going directly into a geosynchronous orbit, and those 4 solid rocket boosters were all needed to deliver this payload. ULA had stated that this was their heaviest payload on Vulcan to date, and including this mission, they've only launched 4 of these since flights began in 2024. Now, did you see that? About 20 seconds in, one of the 4 SRBs encountered another event with its nozzle extension, and the debris, clearly visible, continued for quite some time afterward. Thanks to this awesome tracking shot by Max Evans with NSF, you can clearly see that nozzle burning through. Luckily, this didn't seem to affect the flight profile a great deal, but it resulted in a pretty scary looking roll going on, and at the time, it didn't look like this was going to make it. A brilliant stage separation followed without any trouble though, and the rest of the mission went smoothly. Unfortunately, due to the classified nature of the payload, there isn't a great deal we can dive into, although we believe they did install refueling valves for future hydrazine refill operations, which is always neat technology to see mentioned. ULA soon posted that the Vulcan booster and Centaur stage performed as expected and delivered the spacecraft directly to the intended orbit, while also mentioning the anomaly. From the ground, Greg Scott had some cameras set up with wonderful views like this, but look at the camera itself afterward. He normally sets up in this exact location, and it has never ended up covered with all of this mess, so whatever happened in this flight resulted in the ground just splattered with all sorts of material. An investigation is going to kick off here obviously, so all this is going to likely mean more delays for Vulcan in what has so far been a challenging ride over the past few years, even though in the end each mission has been successful. We have some sweet new updates from Blue Origin, gearing up further towards their first lunar adventure. The Blue Moon Mark 1 lander was shipped to NASA's Johnson Space Center in Texas recently so that it could undergo the thermal vacuum chamber testing. They're exposing this to near space vacuum environment with temperatures ranging from 30 degrees C right down to negative 50 degrees C. Interestingly, according to Eric Berger here, Blue Origin is internally moving aggressively towards a faster alternative to land humans on the moon for the Artemis 3 mission. Of course, this was originally granted to SpaceX, but it is now reopened, and for Blue Origin, this would have needed refilling architecture in place. Now though, they seem to be wanting to go for a lunar lander solution that doesn't require refilling at all. There would instead be 4 launches of the New Glenn rocket. The first 3 would put transfer stages into orbit, with the 4th being the crewed lunar lander itself. The first transfer stage would push the stack into an elliptical Earth orbit. The second would push it the rest of the way to rendezvous with Orion in the near rectilinear halo orbit. After the crew boards, the final transfer stage would lower the Mark II lander into a low lunar orbit before separating for the landing on the surface. One thing's for sure, with SpaceX and Blue Origin both seemingly to be aggressively focusing on the moon, this race is going to be thrilling to watch play out. I would love to know your bets here. Who will actually land humans on the moon first? Meanwhile, Blue Origin has the New Glenn launch coming up, currently scheduled sometime this month, which will reuse the first stage booster for the first ever time. It also seems they are seriously debating whether or not to try to reuse New Glenn's second stage in the future as well. That's because we have seen a new job posting listing a Director of Reusable Upper Stage Development position. This position is tasked with incrementally developing a reusable upper stage for New Glenn, and although this posting went missing this week, that is a curious thing to see. You may recall years ago that SpaceX was going to attempt to design in such a system with Falcon 9, but eventually they chose to push forward with the Starship program instead. The thing is, New Glenn is far bigger and more expensive than Falcon 9, sitting somewhere between that and Starship in its size, so the economics of this may be more worthwhile given that the upper stage uses 2 of these much larger engines. Apparently, the upper stage costs tens of millions of dollars per flight, and that number only goes up with the future plans to upgrade this to use 4 BE-3U engines. I am very curious to see if this plan really does evolve, and if so, how they plan to tackle the atmospheric heating problem with that second stage, and of course, the method of recovery. Now, we have also had Amazon's first mission with Ariane Space launching later in the week from French Guiana. Ariane 6 blasted off in the afternoon with the LEO Europe 01 mission, and as you can see, it was prepared in its more powerful 4-booster configuration designed for maximum payload. Previously, we have seen Amazon send up batches of 24 satellites on Falcon 9 and then 27 on Atlas V. The main difference for the extra 3 on Atlas V, by the way, is simply because SpaceX needs a little extra propellant for booster recovery. With the Ariane 6-4 set up to send up to 20 metric tons to low Earth orbit, they were able to take 32 this time, so it's the largest batch of satellites yet for the LEO constellation. In the future, missions will be carrying even more per launch as added performance upgrades are installed. Getting back to the mission though, just minutes after liftoff, Ariane 6-4 shed its solid rocket boosters and the upper stage was soon away. The stream had soon ended of course, and the deployment sequence began about 90 minutes after liftoff. After a few health checks, the satellites will be raising themselves up to their assigned altitude of 630 kilometers. Now this is just the first of the 18 launch agreements that Amazon has signed with Arianespace. In total, they have over 200 satellites up there now, which means that Amazon is a little closer to being able to start rolling out their services. They still hope for that to be happening in 2026, beginning in northern and southern latitudes and then gradually expanding towards the equator. The FCC, by the way, has just cleared Amazon's second-generation LEO system, which will be a huge expansion in both capacity and global reach. 7,000 plus satellites are agreed to here, and this even adds polar coverage to make the LEO service entirely global. Now, interestingly, this Terran R update from Relativity Space took us by surprise midweek, saying that the vehicle is coming to life. The Stage 2 tank has been going through the process of having the cryogenic COPVs installed, and it looks like it is ripping along nicely. The Stage 1 tank is now in the process of rolling through the integration phase now that the friction stir welding has been done, and if you are watching along like I was, everything just looks so clean at this point. They specifically mentioned that the thrust structure fire sealing and the avionics tray installation is complete, and that the interstage forward barrel has had the machining completed on their vertical turning lathe. The propulsion system, of course, is always a critical part of the build work, and I'm happy to see that they've shipped more first-stage Aeon-R engines to be tested at NASA's Stennis Space Center. This is all while they continue running through the Aeon 5 development testing at the same time. This is a really neat update actually, and they've been putting out these videos every month or so. They have been doing loads of work on the A2 stage test stand, and nearby, the slab is nearly complete and columns are being installed for the new hangar. We've got great views of the work here at Launch Complex 16, and the whole site is really being transformed faster than I thought. All of the siding on the booster processing area is nearly done, and they are ripping into the horizontal integration facility too. They seem to be making some great progress, and they need to if they are indeed still aiming for the first flight late this year. The launch mount concrete has cured now, so the formwork will disappear soon while the steel structure rises. So there we go, my friends. I hope you enjoyed this video. If you did, don't forget to hit subscribe so we get to keep making them. If you want to continue with more space goodness, check out this video here next. And thanks for, just being here, watching and helping us do what we do. I will see you all in the next video.